Let's look at the law of sines and cosines. For example, let triangle ABC be an oblique triangle with A equal to 111 degrees, B equal to 74, and C equal to 29. Let's solve this triangle. Let's begin by marking our given information on the figure here. So we're given that A is 111 degrees, B is equal to 74, and C is equal to 29. And therefore, we're in what's called the SAS case, which stands for side, angle, side. That is, we're given two sides and the angle between them. And when we're in this case, we can use the law of cosines to help us. And here are the forms. Notice that the side that we're squaring on the left is the side that corresponds to this angle over here on the right. And also, the two sides that we're squaring here on the right and adding together are these same two sides here that we're multiplying by 2 and then by the cosine of A. And because we're given A, B, and C, we will be using this first equation here. So we can solve for A as follows. We have that A squared is equal to 74 squared plus 29 squared minus 2 times 74 times 29 times the cosine of 111 degrees. Or A is equal to the square root of all of this. Which, putting in our calculator, gives us that A is approximately 88.6291. So let's mark that over here in our figure. A is approximately 88.6291. Now we need to find capital B and capital C, both of which are acute, right? Because there can be at most one obtuse angle in a triangle. So let's start by solving for angle B, which we can do by using the law of sines. We have that sine of B divided by B is equal to sine of A divided by A. Or sine of B is equal to B times sine of A divided by A, which is approximately 74 times sine of 111 degrees divided by 88.6291. And therefore, B is approximately inverse sine of this 74 times sine of 111 degrees divided by 88.6291. which is approximately 51.2134 degrees. Notice that we didn't need to consider the other angle that's less than 180 degrees, whose sine is equal to this quantity here. Because that other angle would be in quadrant 2 and it would be obtuse, and we can have only at most one obtuse angle in a triangle. And we already were given that A is 111 degrees, which is obtuse. So therefore, this would be our angle B. So let's mark that in our figure here. So B is approximately 51.2134 degrees. And finally, we can find capital C by using the fact that the angle measures in a triangle add up to 180 degrees. That is, C is equal to 180 degrees minus A plus B, which is approximately 180 degrees minus 111 degrees plus 51.2134, which is equal to 17.7866 degrees. So let's mark that here on our figure. C then is approximately 17.7866 degrees. And this is how we can use the law of sines and the law of cosines to solve oblique triangles in the SAS case. Thank you, and we'll see you next time.